Hello, I'm making this video principally for the benefit of Huffington South Downs College A-level further maths students doing the statistics module for OCR during the COVID-19 outbreak of spring 2020. It occurs to me it may be worth making public because it may be of benefit to others. The main focus is for the OCR further maths stats. I'm not aware of it being on many of the other further maths specifications, to be honest. It may be on MEI, it certainly isn't on EdAccelerate AQA. So that's the main focus of this, that's the main target audience, but others might find it useful across the world, I suppose. We'll see. Anyway, there's 5 questions, just to give you a heads up. This is very much a run through. I'm not going through forensically the questions, just the main principles and just how we've got the answers. And I will put up the document, the actual questions on so you ought to be able to see the questions where the homework task came from. First question was a straightforward sign test. The second question is a Wilcoxon signed rank test. The third question is Wilcoxon rank sum test. And then 4 and 5 are all about signed paired data. First, a relatively straightforward sign test. And question 5, quite a nice question where you get to compare the sign test and the Wilcoxon signed rank test. And that will be it. The one thing that's not covered is using the normal distribution on the Wilcoxon test. So that's not covered. That is on the syllabus, but I couldn't source questions easily enough for that. And I happen to know that the question from the OCR further math stats paper of 2019 was on normal distribution of Wilcoxon signed rank test. So in a future video, I will probably go over that question. So it doesn't completely cover everything. The normal distribution you need to be aware of as well, and have a look at that, and maybe have a look at the past paper for OCRA 2019, which involves using a normal distribution. And I think that should give you pretty good coverage of the kind of questions you might likely to encounter. As good as we can get, given the fact that it's new specification. Anyway, so the first question, we've got, it's all about some psychology dissertation involving reaction times. And what we see is that the data is kind of skewed here. It's not symmetrical. And that's quite important because that means we can't do the Wilcoxon signed rank test because it's not symmetrical. Okay, so because it's not symmetrical, we can see that thing there. We can see that because it doesn't not look symmetrical, we can see that we can't use the Wilcoxon signed rank test. So our only option is the sign test. Okay, so we do the sign test, and that's what we get to do in the second part. Don't forget to set up your hypothesis. If you look at this, it says the hypothesis, always look carefully to see what kind of test it is. The results are shown in stem and leaf, and wishes to test whether the median exceeds 180. So that's why we've got that inequality there and this equality here on our hypothesis. But remember, because it's a non-parametric test, we're dealing with rankings and that type of thing, and actually we're losing data effectively because we're not looking at the numbers themselves. We're looking at whether they're either side of the median. So that it's important that we write the hypothesis correctly in terms of median. Okay, now with the sign test, what we basically do is we look, and if we assume that the median is 180, then there's going to be 0.5 chance of it and any particular value being below or above the median. So I'm letting x be 0.5, which under the null hypothesis tells us that where x is number above 180. And under the null hypothesis, p equals to 0.5 under the null hypothesis. So if the median is 180, then we can say that there will be an equal chance of it being either side of 180, so a 0.5 chance of it being above 180. Right, well, here's the thing. We've got 20 values which are above 180. So we want to find the probability of getting 20 or something even more extreme than that using the binomial distribution. And we can see that using the calculator, 1 minus probability of x less than or equal to 19. Let's bring the calculator up for that. Using the 991EX, which is a calculator that we're using, we only get given the cumulative numbers from below. So I've done 1 minus the 19. Now you might have decided to say, well, the probability that it's greater than or equal to 20, you might have adjusted that and said it's the same as the probability of x being less than or equal to 10 or 9 or whatever the number is. But I've decided to go around it long ways just for kind of consistency's sake, really. So we want because we're looking at the null hypothesis, which is greater than 180, the number that we have which is greater than 180 is 20, as we see up here. We've got 20 values up here which are greater than 180. So apologies, the calculator keeps coming up, keeps coming down. Let's just do that calculation. So to get that 19 number, menu 7, we need binomial CD, and we want variable. So if we put the number 19 in, because that's the number we want to deal with, and we put the number the sample size is 30 and p is 0.5, we get that number 0.9506, which I've got there, which then leads us to the 0.0494, which is less than 5%, which leads us to reject the null hypothesis. And we need to give a contextual statement with some level of uncertainty, the language of sufficient evidence to suggest the median exceeds 180. I might actually, I'm reading that again, I'm slightly concerned that I might myself have lost some marks here, that the median, and the data was all about the median time of, she measured median reaction time. Give context every time. Suggest the median is more than 180 or greater than 180, exceeds 180. Use the language that they've used. Exceeds 180 seconds. Okay, that guarantees a should be enough for 4 marks on that question. Right, question 2. There we go. Wilcoxon single sample signed rank test, assuming the distribution is symmetrical. Doesn't ask us to say that, but it does say state any necessary assumptions. So a necessary assumption, which didn't hold in the previous question, is that the parent distribution is symmetrical, and the null hypothesis this time is that it exceeds, is at most 30, so therefore it can't be more than 30, so it's got to be less than 30. I suppose it could be equal to 30, but we don't write that in a null hypothesis. So at most 30, so, or less than 30. Okay, so the way it works, what we do is we actually this row here, I put a row here of how far, positive or negative, they've come from the median as stated in the null hypothesis. So for example, the 3 here is because we've got 3 more than 30, and the 9 here is that we've got 9 more than 30, but we have 29 here because we're 1 less than 30, and so on for the rest of that row. That there is the deviation, the kind of difference from the median. Now what I do then is rank them, but rank the modular, the magnitudes of them. So I'm kind of ignoring the negative sign. So the smallest absolute difference is 1. Okay, it's -1, it's below, but it's the smallest distance it is from the median, so that's 1. And then the next smallest is 2, because that's only 2 from the median. The next smallest is 3. And the next smallest is 4, dropping the negative because we're looking at the modulus of them. Then what we do for the final bit is keep the magnitudes the same, but actually then refer back to whether it was above or below the median. So if it's below the median, the signed rank, it will be negative, and if it's above the median, the signed rank is positive. So we're just looking to change, basically if we have a negative here, we put a negative in this row here. Okay, some people put extra rows in, but that to me makes sense. So first row, just put the differences in. The second row, put the absolute rankings, so not worrying about whether it's negative or not. And then with the same number, the same actual absolute values there, then refer back to whether it was put above or below the median, and then putting a negative in if it's below and a positive, and leaving positive if it's above. Okay, so then what we do in this case, we look for, W plus is assigned sum of the positive ranks. So we got all, not the -4. So that's all those 4. No, not that one. Sorry, the negative has been rubbed out by accident. So the -4 there. So it's all of those numbers here. Okay, so that's all of these numbers here is those there added together, 31. Okay, and then for this one we're just adding those two numbers together. Okay, and getting 5. But it's obviously we're interested again in the magnitude of that, and our value of t is the smallest of these. That's our value of t, which is the smallest. Okay, so I probably ought to write that in. Let's put in a different color, the smallest. Okay, smallest is t is 5. Now, then we compare with these preset. Now, these tables are the ones given in the OCR exam. And what we do is we look for, remember it was one-tailed at 5%, and our sample size was 8, so the critical value is 5. Okay, so the critical value is 5 from there, which is the same as the actual t value. So if they're the same or smaller, so if we had a critical value of 4, we'd be rejecting H naught. If we had the critical value of 3, we'd be rejecting H naught, and so on. But if they're the same or smaller, then we reject H naught. So because we've got 5 as our actual t value and 5 as a critical value, we're rejecting H naught. And again, give a contextual statement. There is sufficient evidence to support the manufacturer's claim. I've probably written more than I need to here, that on average people take painkillers, feel relief for at least 30 minutes. Okay, so there is that as sorry, at most, not at least. Good to, it almost serves to actually check my own work here. At most 30 minutes. Okay, So that's the second question done. Right, the third question is a Wilcoxon signed, Wilcoxon rank sum test. Here we've got results from two different types of people, smokers and non-smokers, and we were testing the pulse rate of the smokers in beats per minute. So basically it says it may be assumed that there were random samples from student population of smokers and non-smokers, and that the shape of those distributions is similar, although it doesn't say that there. So the Wilcoxon rank sum test. Right, so what we do, and this is where these numbers I've written up here are, I've ranked these in order here. So the smallest is 1, next smallest is 2, the next smallest is 3, but then 68, 77 is the next smallest after that. So whichever list that they're in, I'm just ranking them. So and then the largest finally is the 98, which is 7. So that's where those numbers come from. Okay, so so what we do then is work out the RM value, which is the sum of the ranks of the smallest one. M is the small, so in this case M equals to 4 and N equals to 5, because M is the smallest one, and RM is the sum of the ranks, so it's the sum of these numbers here. Okay, so let's just rub these out. Okay, so and that's it. So okay, so what we do then is work out this total here, which is basically, or sort of minus RM here. So we work out what RM is, which is the sum of these ranks, and we work out this alternative total, which is this total here, and work out what that is. And our W value, the value that we're going to use as our test statistic, is equal to the smallest of these. What's happening here is basically this number here, when you're taking away from the total M times M plus N plus 1, gives you what the ranking would be if you went in the opposite direction. So in other words, 9, you started from the smallest to the largest. So the test statistic is the one which is the smallest of those, in which case is 13, because 13 is smaller than 27. Okay, so 13 is smaller than 27. So the value of our test statistic is 13. So we look to see where what the critical value is. Remember, it's 4 by 5. M is 4. That's 5. The test, because are not equal, was two-tailed, because it's not. I'm not saying they're greater or equal to each other, and that's implied in the question. Using the test whether there is a difference. It doesn't talk about it being higher or lower. So we're looking at two-tailed, 5%. Okay, two-tailed at 5%. No, two-tailed at 10%. So two-tailed at 10% is there. The critical value is 12. We need 12 or lower to reject the H0, and we've got 13 for our test statistic. So we do not reject H0. There is insufficient evidence to suggest there is a difference in the medians of, what was the thing about, of reaction times. It's always give context times between smokers and non-smokers. Smokers and non-smokers. Okay. Let's go on to the next question. Question 4. Now, question 4 is or not. Here it's not a paired test. I said it was a paired test originally, but it's not, is it? It's not a paired test. Question 4. Question 4, we just got 20. We got 20, and it's another sign test. Effectively, we've got 20 specimens of a particular alloy, and we're testing whether it's greater than 270. So this is another sign test, really, very similar to the first question. And what we find is that there are 13, which are circled there, above the median. So to work that out, I won't bring the calculator up again. We do 1 minus x is less than or equal to 12, which gives us 0.1316, which is greater than 5%. Okay. And that means that you do not reject H0. There is insufficient evidence to suggest median levels of impurity is greater than 2.7. I think I must have put this question in mainly because of this. Can't stress important enough. What other tests might have been used, and give one advantage and one disadvantage. So whenever you have the Wilcoxon signed rank test, the equivalent, another test that could be used is the sorry, I've got that the wrong way around. Whenever we use a sign test, we should consider whether a Wilcoxon rank sign test will also be a better bet, because they do the same thing. They test for median for unpaired data. However, there is as we've mentioned before, it assumes the distribution is symmetrical. So that's a disadvantage of using a Wilcoxon signed rank test, because it assumes the distribution is symmetrical, and that might not be a reasonable assumption. So there's a disadvantage for you. However, if we think that you can assume that it's reasonably symmetrical, then we should go for the Wilcoxon signed rank test, because it has greater power. Okay, since it takes into account how far the data is from the median. We'll see this in the next question, actually. But if you're given an option between the two and you can assume it's symmetrical, the Wilcoxon rank sign test will do a better job generally, because it takes into account how far certain values are from the median. It's in technical, it's not actually part of the OCR spec to talk about for false type 1 and type 2 errors and whatever, but the advantage with the Wilcoxon rank sign test is it is less likely to produce a type 2 error. That means that it is less likely to incorrectly not reject the null hypothesis. So in other words, you might have something significant going on, that there may be a change or an increase or a decrease in a certain value. There may be something significant, and the advantage is the Wilcoxon rank sign test is more likely to pick that up. And actually that leads nicely into the next question, where this actually happens, where the two different tests come to different conclusions. Okay, so let's just have a look at this. So in question 5, we've got a question which is involving paired data. Now, we shouldn't just assume because we've got the same number in each group that it's paired, but definitely here, because we're talking about different employees, we should be dealing with the data in pairs here rather than as a whole, because each employee, it makes sense. You lose the information if you uncouple those two, because each employee is a distinct entity. So we really want to be pairing the data. Okay, so that's important. It doesn't say that in the question, but it is important we recognise paired data when we see it. And it shouldn't be assumed just because the number sample size in each one is the same that it's paired. Obviously, it has to be the same. There has to be the same number in each group for it to be paired, but that doesn't necessarily mean it is. But here, because we're looking at each individual employee, it's definitely paired data. anyway, that's not the first question, but just giving a bit of background to it. So state the circumstances in which a non-parametric test should be used. Well, if we don't know much about the parent distribution, you might know it's symmetrical, but if we don't know exactly how it's distributed, for example, if it's normally distributed, then we might use a non-parametric test. And it did occur to me also we should say that the sample size is small, because even if we don't know much about the parent distribution, normally if the sample size is reasonably large, over 30 say, then we can use the central limit theorem, but we can't if the sample size is small, which it is in this example exactly, which is why we're going on to do a non-parametric test, because we don't know what the distribution, exactly what it's like, what the parent distribution is. Not assuming anything about that, don't want to assume anything about that, and also the sample size is small, so we can't use central limit theorem. Okay, so let's get on with the second part. I've written the table down. Remember it's all about the time taken in seconds for employees to different employees to make a table. Okay, so this column, this row here, what I've done is I've worked out what the differences are in the between the median and between the values, whether they're positive or negative. Now, if we think that there isn't any difference between them, then the median of D would be equal to 0. Whereas if we think there is a difference, remember the hypothesis is that so the levels lead to different conclusions. So the company wishes to test whether there is any difference. So it's two-tailed, not one-tailed. So whether there's any difference in the time taken. And if there is a difference in the time taken, and a difference in the median time taken, then we would expect the median to be not equal to 0, which is our alternative hypothesis. Well, I'm going to do the sign test first. So in this case, we've got the two options: the sign test or the Wilcoxon signed rank test. So let's do the sign test first. We don't actually need the absolute values of how far they are from how far what the difference is here. The important thing here is whether the difference is positive or negative. Okay, so I've let X be the number of times Vivance takes is less than Allegro. So the number of times it takes less time for Vivace to take less time than Allegro. Okay, and in this particular example, because the negative differences there's negative differences 1, 2, 3, 4 times. Okay, 4 times out of 12, the difference is negative. Okay, again, I've used a calculator, the FX911EX. Let's bring that. Remember, we want to find the probability of getting 4 or something even more surprising, or something even more extreme than 4, something even, it would be more surprised under the null hypothesis, and if none of them were led to a negative difference. If our null hypothesis is that they're basically the same, then we can say that then that would be surprising. So we've got 4, which is less than what expected. Our expected on average would be 6. We've got 4 here. So we're finding a probability of 4 or something a little bit more extreme than 4. So that's 4, 3, 2, 1 or 0. But instead of adding those together, use your calculator, menu 7, and we can go to normal CD and go to list, go to variable. And this time the sample size was 12. Oh, no, the number, sorry, is 4. And we've got 12. And 0.5, which leads to the number 0.1938. Now, that is nowhere near greater than 5%. It's nowhere it needs to be below 5% to reject H0. It's a long way above. So do not reject H0. There is insufficient evidence to suggest time taken for Allegro is different to Vivace. Okay, so that's the sign test which led to not rejecting the null hypothesis. The Wilcoxon-signed rank test. I've written the tables of differences up again now, but this time we have to do a bit more work. We have to rank them. Remember, as I say, I talk about the absolute ranks first of all. So that, for example, employee 3 is only one from one for different. The difference is only one, so that's the smallest. And employee 7, the difference is only 3, so that's the next smallest. And for employee 6, the difference is 5. Yes, it's the other way round. It's less than, but we can still call that the absolute rank. The absolute difference is 5, so that's the third smallest. And then in this final row here, what we've done is we've picked up whether it's negative, whether it's a negative difference, and attach that to the ranking. Okay, so sorry about that. So and that's our ranking. So we work out our W plus and W minus. Clearly W minus is going to be the least of these numbers. So the W minus, the absolute difference of all of these added together, is equal to 13. Okay, and then what we do is we look for that number in our critical value of tables, which we can see here. Sample size of 12. We go back to the actual test. It was two-tailed at 5%. So two-tailed at 5%. We have a critical value of 13, which is exactly the same as our test statistic. That's our test statistic. So our test statistic is exactly that critical value. Now remember, the critical value is the smallest it can be to reject H0. So it's just about small enough to reject H0. So 13 or less would reject H0. We've got 13, so we just about got enough to reject H0. So there is sufficient evidence to suggest that there is a difference in times taken to make Allegro or Vivace chair legs. Okay, so that was that question 4 led quite nicely into question 5 there, because in this particular example, so it's how more powerful the Wilcoxon signed rank test is compared to the sign test. The Wilcoxon test has picked up the fact that the negative ranks are small in magnitude compared to the positive ranks. Because if we go back to the rankings here, the negative ones are quite small relatively. The negative ones are the ones where the differences aren't that big. And that's made a big difference to the test. That information is lost when we do the sign test. It's our only option if we didn't, assume it was symmetrical, but this is more powerful, and we've probably, obviously there's a chance that we've come up with a type 1 error, that we've incorrectly rejected H0, but that chance is only 5%. Chance that we've rejected H0, there's always that danger, we're never certain of anything, but in the longer run, if you apply the Wilcoxon signed rank test, you will more often correctly reject H0 and and less often incorrectly reject H0, which after all is often what we're trying to do when we're doing hypothesis testing. Okay, so there, and I'll just put a final note in there. If the assumption of a symmetrical distribution is reasonable, then the Wilcoxon signed rank test is the one to go for, generally speaking. Okay. Right, that's it. I hope you found it useful. I'll try and make sure that I put the actual questions up on the video, just so that you can actually try the questions out yourself and work them out, and maybe view the video after having had a go yourself. Okay, cheerio, bye.